Hello dear students. Today we will be discussing about measurement of temperature. So we have two devices, resistance temperature detector and thermistors. So first we will see resistance temperature detector. So this is an electronic device used to determine the temperature by measuring the resistance of the electrical wire. So in a normal conductor or a metal, the variation of the temperature is given by this particular equation. RT is equal to R0 into 1 plus alpha T plus beta T square plus gamma T cube and so on. And R0 is the resistance at T0, which is generally at 0 degrees Celsius, and alpha, beta, gamma, etc. are the temperature coefficients, that is first order, second order as well as third order temperature coefficients, and RT is the resistance to be measured, which is at a temperature T. Okay, so this can be taken as T, capital T. Okay, so with the change in temperature, how the resistance is varying, that is being given by this particular equation. Now the principle of operation of RTD is very simple. So the resistance of the metal changes in a very linear as well as repeatable manner when temperature varies. So a RTD or resistance temperature detector measures a change in resistance when temperature varies. So once you have a variation in temperature, the resistance increases. So that particular effect is being recorded as a variation in resistance. Okay, so RTDs have positive temperature coefficient, that is, as temperature increases, the resistance also increases. So this is the relationship between temperature and resistance. And once the temperature increases, you can see an appreciable change in resistance. So once by measuring the resistance, you can indicate the change in temperature or increase in temperature or decrease in temperature. So the materials, there are many materials that can be used to make RTDs. So some of the requirements of these resistive materials are: should have high temperature coefficient, high resistivity, it should have a linear relationship between resistance and temperature, that is, once the temperature varies, it should have a linear relationship so that you are able to easily establish the temperature relationship. Once the temperature varies by 1 degree, if it is varying by some particular value of ohm, you are able to easily establish that relationship. And the material should be malleable, that is, it should be able to withstand the mechanical strength, as should have good mechanical strength, as well as it should be able to draw into thin wires, so that you are able to make different types of RTDs. Now this is the characteristic graph for RTD, your variation of resistance with temperature. So here we are marking relative resistance, that is RT by R0. RT is the temperature resistance at a particular temperature T, and R0 is the resistance at the reference value. Now we have different materials that can be used. You have nickel, Balco. Balco is a alloy of iron. Then you have platinum, etc. Now you can see that once the temperature varies, the resistance is increasing, and the most commonly used metal is platinum, because it is having a linear relationship between temperature and resistance. Others are also having a linear relationship, but only in very small range. If you take the case of nickel, it has a linear relationship in somewhere in this range. Okay, so from 0 degree up to say 300 degree Celsius. But for a platinum, the relationship is linear for a large range of temperature, minus 263 degrees up to close to 600 degrees. You have a linear relationship between temperature and resistance. So it is useful. It can be used for a larger range of temperatures for measuring different temperatures. Now again, platinum is a stable element. It has less corrosion, and it is easily workable, or it is malleable. It has a high melting point, so that it does not melt with increase in temperature, and can be easily purified and processed, and can be formed in the form of resistors. Now thermistor is, you can see that this particular RTDs are having positive temperature coefficient, that is, it is having positive slope. As the temperature increases, resistance increases. So that is the concept of positive temperature coefficient. And thermistor is another kind of temperature measuring device. or a transducer, which will be seeing in the end of, towards the end of this session, and it is having negative temperature coefficient. You can see that the temperature resistance is reducing as the temperature increases. So thermistor is having a negative temperature coefficient, and RTDs are all having positive temperature coefficient. That is, resistance will be increasing with respect to temperature, and we will be making use of this particular property to measure the temperature. Now, that resistance, this RTD is also known as resistor thermometer. So it is the wires are taken and it is placed inside the protective tube to provide protection against the damage. So this is a protective tube that you have. So you'll be placing this particular resistive element within this tube, and this resistive element is formed by placing this platinum wire on a ceramic bobbin. So you have a ceramic bobbin here, so you'll be placing this non-inductive platinum or winding this platinum element here, and you are insulating this to prevent very high temperatures affecting it. So this entire setup is placed in a stainless steel shell or a tube or a copper steel, and you are provided with the connecting leads to connect it to that external circuit, so that you are able to measure, you are able to connect it to circuit for measuring purpose. And lead wire is covered by the insulated tube. Okay, so you have an insulated tube here. So it prevents short circuit between these leads. So you have an insulated tube and has some gap between them, so it provides insulation. And ceramic material is used to cover everything. So you have some ceramic material to use as an insulator for high temperature material. When you are trying to measure high temperature, so you are using ceramic material as the surface coating material, and if you are going for low temperature, you will be using fiber or glass as the covering. So that's how you construct the RTD. And these are different types of RTDs available. This is the surface. This is a kind of RTD which is used to measure the surface temperature. It is flat in structure, so you have platinum wire placed here in zigzag manner. So this is used to measure the surface temperature. Now you have different types of RTDs. Some of them are this is a stainless steel probe, and this is a surface sensors, very similar to this. Surface sensors used to measure the temperature of surface, different surfaces. And this one is epoxy glass laminated stator RTD. So this is used to measure the temperature of stator windings in electrical machines. So you will be inserting this particular RTDs into the stator winding, between the windings or to the stator winding, and you are able to measure the temperature. And these are miniature kind of embedded RTDs which are used in applications where your space requirement is very minimum, or space is very less, so that you are able to insert this miniature type of RTDs and you are able to measure the temperature. So these are there are many other products available. These are some of them which can be used to measure temperature. All of this works and by the principle of positive temperature. So the advantages of RTDs are listed here. So it is having a low resistance, so that it doesn't affect the resistance or the resistance of the total circuit to which it is connected. It is having high sensitivity compared to thermocouples. Thermocouples will be looking into this in future lecture. And sensitivity in the sense it has a better response to temperature. When temperature varies, resistance varies in a better manner, so that it is highly sensitive. It is able to measure small variation in temperature effectively. It is highly accurate, and we have already seen that it is linear over a wide range of temperature in case of platinum kind of RTDs. And it has wide operating range, and it is able to operate at high temperature. We have to provide some protection for operating at high temperatures, and it is highly repeatable and stable. In the sense, you are able to get results repeatedly using the same setup, even if you do it at different periods of time. And the variation in results, drift is very low in case of industrial models, and in case of precision RTDs, where your precision is very high, the drift is very small, in the range of 0.0025 degree Celsius per year. So per year it varies only this much value. So it is highly repeatable as well as stable throughout the throughout its operation. Now, some of the disadvantages are they are expensive in case of platinum, low static sensitivity, that is, they have, sensitivity is low when it is used for measuring one particular point of one particular value of temperature, static value of temperature, and it requires excitation and supporting circuitry because it is a passive device, it's a resistor, so it needs a supporting circuitry to get the output measurement, and it is very fragile since you are making it into very thin wires or extending it into thin wires. It is sensitive to shock and vibration, and it has low absolute resistance. So resistance of low absolute resistance and lead wire resistance may affect the accuracy. It has self-heating error, as well as response time is also slow. Self-heating in the sense, once the resistance varies and the current flows through this particular setup, you will have heating within this device, so that will be introducing some errors. And with respect to variation in temperature, the response is also slow. That is, once the temperature varies, the resistance will be the resistance change will be slow when compared to the change in temperature. So in that sense, the response time is also slow. So these are some of the disadvantages that you can think of in case of RTDs. So thank you so much.